Hello, hi everyone. Welcome to the Student Brand. This is your Sivasa. Today we are going to discuss about electric current, CBSE Grade-10 physics. So today, uh, along with the concepts, we'll do problems. Okay. So let's start. Hi, welcome to the class. Okay. So electric current, electric current, electric, electric current, electric current. So inform to everyone, ma. So class is going on. Okay. So electric current is nothing but the rate of flow of charge is called electric current. I equal to Q by T. I equal to okay. So I equal to Q by T. I equal to Q by T. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second, right? That is called electric current. I equal to Q by T. I equal to Q by T, right? Okay, done. So now we can see, so electrons are moving in the conductor, electrons are moving in the conductor. So only 1 electrons, 2 electrons, 3 electrons, so 4 electrons, okay. So 5 electrons, 6 electrons flows. We can't say current is flowing. There are many electrons. Many charges are moving in the conductor. Then only we can say current is flowing. Many charges are moving in the conductor. Then only we can say current is flowing. Right? Yes. So here I can say, so 1, 2, like this. It's going on. It's keep on going like this. It's keep on going like this. Right? So Q equal to Ne. Quantization of charge. Quantization of charge Q equal to Ne, right? So I'm taking Q equal to Ne. So we can take plus or minus. So why you are saying plus or minus? Plus or minus is nothing but positive charges are there, negative charges are also there. Positive charges are there, negative charges are there. That's why we are saying okay. So plus or minus, we can say plus or minus, right? Yes. So now we can take on 1 electron 1.6 into 10 power minus 19 coulomb. On 1 electron how much charge is present? On 1 electron 1.6 into 10 power minus 19 coulomb present. So in 1 coulomb how many electrons are present? On 1 electron 1.6 into 10 power minus 19 coulomb. Okay, in 1 coulomb, so 1 by 1.6 into 10 power minus 19, then you will get, so 1 by 1.6 into 10 power 19. So if you solve this one, you will get 0.625, 0.625. So 0.625 into 10 power 19, 10 power 19. Okay, so if you do this one, you'll get it, you'll get the final value, okay. So you can see you'll get the final value is, so 6.25 into 10 power 18 electrons, 6.25 into 10 power 18 electrons in 1 coulomb. So you'll get 6.25 into 10 power 18 electrons are present. So this is about electric current. I equal to Q by T. 1 ampere is SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. Okay, so quantization of charge is nothing but there are many charges are moving in the conductor. So there are many charges are moving in the conductor. Then we can say current is flowing. So that is quantization of charge. Q equal to Ne. On 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 1 by 1.6 into 10 power minus 19. If it is goes up, so in the numerator it will become numerator. Okay, so then you will get, so 1 coulomb 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. I hope it is very clear, right? So this is the answer. Now you can see, so that is about quantization of charge and electric current. So now we will discuss about electrical elements. Okay, so we will discuss about electrical elements. Let's discuss electrical elements. Okay, so see, one is, so we can say first one is cell. So this is the cell, positive terminal, negative terminal cell. And the second one is battery. So this is the battery, this is the battery. If you are taking this is the battery, positive terminal, negative terminal battery. And next one you can say third one is open switch. Open switch. Third one is open switch. Next one is closed switch. So I am taking this open switch. Open switch. Open switch. And the next one we can say closed switch. Fourth one is closed switch. This is a closed switch. So dot is there. If dot is there, that is closed switch. If dot is not there, that is open switch. Okay, open switch. And fifth one is resistor. Resistor is a device. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistor is a device. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Okay, so now you can see here. So now we are discussing about a closed switch. Next one resistor. This is the resistor. Resistor. Next one rheostat. Sixth one is, so we will discuss about rheostat. Rheostat is a device. This is a rheostat. This one rheostat. Okay, next one is, seventh one is ammeter. This is the ammeter, positive terminal, negative terminal. Next one voltmeter, like this, positive terminal, negative terminal. Okay, next one is ninth one. Ninth one you can say, ninth one is wire joining. This is a wire joining. And 10th one is wire crossing. You can say wire crossing. This is a wire joining and wire crossing. Just if you are taking like this, simply we can take wire crossing. And next one is the bulb. Okay, so bulb symbol we are taking. This is a bulb symbol. Like this I am taking this a bulb symbol. Okay, so first one cell, battery. First one is here you can see, this is a cell, battery, open switch, closed switch, resistor, rheostat. So resistor and rheostat, here I am taking rheostat. And next one this is the ammeter, voltmeter, and wire joining and wire crossing. And bulb. Okay, so from here we have to discuss resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current, and SI unit of resistance is ohm. SI unit of resistance is ohm. I hope it is very clear. Right? So that's enough. Next one, rheostat. Rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. So rheostat can regulate the current. Okay, that is called rheostat. And coming to the ammeter. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current in the circuit. Voltmeter is a device which is used to measure the potential difference. Ammeter will be connected in series combination. Voltmeter will be connected in parallel combination. Okay. So this is about ammeter and voltmeter. Next one, wire joining and wire crossing. Anyway, bulb. So we discussed about it. Next one, so we will discuss about electric circuit. Okay, let's start electric circuit. Electric circuit. Electric. Electric circuit. Electric circuit is nothing but a closed and continuous path of an electric current. A closed and continuous path of a closed and continuous path of an electric current is known as an electric circuit. A closed and continuous path of an electric current. Okay, so here you can see. So I'm taking the bulb is here. This is a bulb, and I'm connecting ammeter here. Ammeter. Next one is so battery. Battery I'm connecting here like this, and a switch you can see. So current is passing, positive terminal, negative terminal, current is passing. So here positive terminal, negative terminal. So the bulb is glowing. The bulb is glowing. Okay, because the circuit is closed. The circuit is closed. So because of that reason, the bulb is glowing, right? Yes. So point number one, here two types of current. One is positive conventional current, another one is electric current. Conventional current, the flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Flow of positive charges. Flow of positive charges is known as conventional current. Flow of electrons is known as electric current. First one is conventional current. Conventional current. Conventional current. And the second one is electric current. Electric current. So you can see here electric current. So conventional current is nothing but the flow of positive charges. Positive charges are moving. Okay. So positive charges are moving from positive terminal to negative terminal. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Negative terminal to positive terminal. So conventional current. Positive charges are moving from high potential to low potential. Positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Low potential to high potential. So you can see here positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. So you can observe. So this is about high potential. Positive plate has high potential, negative electrons. So negative place has low potential. So then positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. So conventional current. Conventional current is nothing but flow of positive charges is known as conventional current. Flow of electrons is known as electric current. A closed and continuous path of an electric current. Okay, closed and continuous path of an electric current is known as an electric circuit. Okay, so that is about conventional current and electric current. So now we will discuss about potential difference and electrical potential difference and electrical potential. So we will discuss those points. Potential difference. So what is the potential difference? Work done to bring unit positive charge. Potential difference. So you can see here potential difference. So work done to bring unit positive charge. So I'm taking the conductor. This is the point A and this is the point B. So positive charge, we are doing some work. So work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. Okay. So 1 volt is defined as 1 joule of work is done to bring 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point, that is called potential difference. Coming to electrical potential, work done to bring electrical potential. So here you can observe electrical potential. Okay, electrical potential. Work done to bring unit positive charge from infinity to the required field. So I am taking this to infinity. Okay, so positive charge is there. So we are doing some work. So this is the required field. So we are doing some work to bring. Unit positive charge from infinity to the required field. So V equal to W by Q. So potential difference is nothing but work done to bring unit positive charge. From infinite, from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from infinity to the required field is called electrical potential. So this is the difference between potential difference and electrical potential, right? So now we will discuss about Ohm's law. So Ohm's law is about completely the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, so the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So I'll explain the everything, right? Okay, so let's start. Ohm's law. So potential difference is directly proportional to, so V is directly proportional to I. Okay, so V equal to I. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. So coming to the materials, what are the materials required? We will see now. Materials required. So materials required. First one is 4 cells. So each cell is 1.5 volts of each. And second one is nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So 0.5 meter length. And the next one is, so third one is ammeter. We can take ammeter. And coming to the fourth one is voltmeter. Ammeter and voltmeter. And the next one is, fifth one is switch. So we can go for switch. And the sixth one is connecting wires. Okay, so connecting wires. So these are the materials required. Now circuit diagram. So we'll discuss about circuit diagram. So just check once. So 4 cells. 1, 2, 3, 4. So 1, 2, 3, 4. So I'm taking like this ammeter. And so here is the resistor, switch. And here you can observe. So across this one voltmeter I'm connecting. So current is passing here. So here also current is passing, current. So resistors, okay. So now you can observe here 1, 2, 3, 4, okay. So now you can see here, now I am taking 4 cells, okay. So this is about 4 cells. So those I am connecting here. I am connecting. Now you can observe. First one is, so procedure to do this procedure. First one is connect one cell and note down the reading of ammeter and voltmeter. First you have to connect one cell and note down the reading of ammeter and voltmeter. So next connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, and mention in the tabular form given below. First one you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to two cells and observe the reading of ammeter and voltmeter, and repeat the process for 3 and 4. Repeat the process for 3 and 4 and mention in the tabular form given below. So I am taking here, so this is the tabular column. Okay, serial number of cells, ammeter reading, voltmeter reading, V by I form. So 1, 2 and 3. Okay, so here I am considering like this. Okay, so here you can observe serial number, number of cells, ammeter reading, voltmeter reading, V by I equal to R. Okay, so now you can see 1, 2, 3, 4. 1, 2, 3, 4. So first you have to connect one cell and note down the reading of ammeter and voltmeter, and so repeat the process for 3 and 4 and mention in the tabular form given below. So this is a tabular form given, so you have to mention in the tabular form. Then you can take, so then you can draw the graph for VI. The graph is VI, so VI graph gives straight line. So V on y axis, I on x axis. The graph is straight line for ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. So here I am considering this non-ohmic conductors like this. V on y axis, I on x axis. So the graph is curve. Okay, so I hope it is very clear. Once again check. So V is directly proportional to I. So the potential difference across the ends of the given metallic conductor. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature, and physical conditions also same. So V is directly proportional to I. V equal to IR. Okay, so materials required. So what are the materials required? First one is 4 cells. So 1.5 volts each. Nichrome wire you are taking. Ammeter, voltmeter, switch, connecting wires. Okay, so after that you have to connect. First you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4 mentioned in the tabular form given below. So then VI graph gives straight line. So that is for ohmic conductors. For non-ohmic conductor, the graph is curve. Okay, so this is about Ohm's law. Now, so we will discuss about next one. So now we will discuss about difference between resistance and resistivity. Difference between resistance and resistivity. Okay, so now we'll see. R is directly proportional. Resistance and resistivity. Resistance and resistivity. 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 Okay, so resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So resistance depends on temperature and resistance depends on nature of the material, nature of the material or material of the conductor, nature of the material. And coming to your resistivity, so rho equal to Ra by L. Rho equal to Ra by L, right? So now SI unit, rho equal to ohm meter square. So you can see ohm meter square, ohm meter square by meter. So meter get cancelled. Meter get cancelled. So the remaining values you can observe. So rho equal to ohm meter. So this is the SI unit of resistivity. SI unit of resistivity. So this question come for 2 marks. So very important, 2 marks question. Very important, very important. So make sure that you are practicing this one. So V equal to, very important point, very important. Okay, and here so this difference also they will ask for 2 marks. Differences they will ask, and this depending factors, everything they will ask about it. And here this especially this SI unit of resistivity. SI unit of resistivity is very important. SI unit compulsory they will ask, so make sure that you are practicing this one. SI unit of resistivity. Okay, SI unit of resistivity. So rho equal to ohm meter. So differences once again. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So resistance depends on temperature. Resistance depends on nature of the material. Resistivity is R rho equal to Ra by L. Rho equal to ohm meter. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. So meter get cancelled. Then the remaining value is rho equal to ohm meter. Rho equal to ohm meter. Okay. ఓకే మా సో తెలుగులో కూడా మనం చెప్పుకోవచ్చు. సో వీ కెన్ డిస్కస్ ఇన్ తెలుగు ఆల్సో. సో క్లాసెస్ స్టార్ట్ చేద్దాం. ఓకే, సో డెఫినెట్లీ. సో చాలా వీడియోస్ ఉన్నాయి తెలుగులో కూడా, చాలా వీడియోస్ చేశాను ఈ టాపిక్స్ మీద. ఒకసారి చెక్ చేయి, ఛానల్ ఒకసారి చెక్ చేస్తే నీకు అర్థమవుతుంది. సో ఎస్, రైట్, ఓకే, డన్. So this is about difference between resistance and resistivity. I hope it is very clear. Now we will discuss about resistors are connected in series combination. Resistors are connected in parallel combination. Let's discuss those points. Resistors are connected in series combination and resistors are connected in parallel combination. We will discuss. Resistors are discussed in series combination and resistors are discussed in parallel combination. Okay, resistors are connected in series combination. Resistors are connected in connected in series combination. Okay, series combination. So let's discuss. Okay, so the three resistors are connected in series combination 1 and 2 and 3. So three resistors. So ammeter is connected and next one is battery and a switch like here. So current is passing positive terminal, negative terminal, right? So across R1. So this is R1, R2, R3, R1, R2, R3. So actually, you can check my videos. So many videos I did with different designs and different experimental videos related to physics only. So once you go and check those videos, so you can, if you like the content, if you like the channel, you can subscribe the channel. You can share to your friends, ask your friends to join to the class. Okay, so this is very important because now we are going to discuss about CBSE grade 10 physics. Live classes are going on continuously. Okay, so live classes will be going on throughout the day, so you can join to the classes. So CBSE grade 10 syllabus will be teaching. So right now we are discussing about CBSE grade 10 physics. So in coming I will start those series. So one by one live class also I'll take. Okay, so grade 11, grade 12 and like that. So I'm going on now CBSE grade 10 physics. So vigorously we are going with the live classes because the exams are coming up. Okay, that's why. Okay, so do like, share, and subscribe to Student in the Brand if you like the content, if you like the channel, if you like my explanation. So you can go for super chat, super thanks, and be a membership. And coming up, doubt clarification session will be going on for members only. Okay, like for them only classes will be conducted for CBSE grade 10 students. So for members only live classes will be taken. So you can check today also I started the class. So membership, okay, for those who are there in channel members, for them only I'm taking classes. Okay, so individually those who want for doubt clarification and especially preparation like that. So remaining live classes will be going on. So okay, so it goes on. So try to attempt the classes, try to attend the classes regularly. Inform your friends, share to your friends, ask your friends to join to the classes. So CBSE grade 10 physics. So without any deviation, it goes on. Okay, so it goes on. So it continuously goes on CBSE grade 10 physics syllabus. Okay, so continuously live classes only I'll be taking. Live classes only I will take and I'll explain the concept based on that one problems discussion. Okay, so it will go on. Be a member to the channel, so you will get benefited definitely. So membership live class also I'll be taking. If you like the content, if you like the channel, please do like, share, and subscribe to Student in the Brand and inform to everyone as much as possible, as many as possible. You can inform to everyone. So ask them to join to the class and listen to the class if they like them. So ask them to subscribe the channel. Okay, say yes. Now we can take R1. So this is R1, R1, R2 and R3. So across R1 I am connecting V1 and across R2 I am connecting V2 and across R3 I am connecting V3. So like this. So positive terminal, negative terminal, positive terminal, negative terminal, positive terminal, current is flowing like this. R1, R2, R3, R1. So I need your support in order to take the channel to the newer level. Okay, so within our hands only it is there. So with your support, with your encouragement, then only I can able to reach to the maximum number of students. So the content is very good. So key is the content only. So content should reach to the maximum number of students. So if you like the content, if you like my explanation, So if you really the classes are worthy, means try to inform to everyone. Okay, so there is a physics CBSE grade 10 physics class are going on. So in the student brand, just once check, like that inform to everyone. So just spread one word regarding the channel. So that is support I want from you all. Okay, I need your support. Without support only, so with your support only I can able to go to the uh, maximum number of students. I can reach to the maximum number of students. So thank you so much for supporting those who are supporting from day one onwards continuously. So thank you so much. So I request remaining students also try to support the channel, try to encourage the channel, try to support the content. So take this channel to the newer level. Okay, inform to everyone. Thank you so much. And now, so please do like and share and subscribe. Thank you. Okay. So here in this resistors are connected in series combination. Current is same. Is equal to I1 equal to I2 equal to I3 equal to I, because current is same throughout the circuit. Current is same throughout the circuit, but potential difference is different. Potential difference is different. Then we can take Vs equal to V1 plus V2 plus V3. So IRS equal to IR1 plus IR2 plus IR3. IR3. Okay, so I'm taking I common. So if I take, so you can take I common, then you'll get I you are taking common, R1 plus R2 plus R3. So I get cancelled. Then RS equal to R1 plus R2 plus R3. Okay, so this is about resistors are connected in series combination. Resistors are connected in series combination. If n number of resistors are connected in series combination, RS equal to NR. RS equal to NR, right? RS equal to NR. So this is the answer if n number of resistors are connected in, if n number of resistors are connected in series combination. Once again you can observe here. So R1, R2, R1, R2, R3 are connected in series combination. Ammeter. Okay, so here you can see, so positive terminal, negative terminal, current is passing like this. So this is the way the current is, direction of the current. Here also direction of the current. So across R1 V1, across R2 V2, across R3 V3. So current is flowing like this. Okay. So if you want to know the reason behind of this costume, just go and check the channel. So check all the video, then you will get to know. So different with the different costumes, with the different experiments only I'm doing physics. So just go and check, then you will get to know. So current is passing like this, R1, R2, R3, across R1 V1, across R2 V2, across R3 V3. So current is flowing like this. So current is same throughout the circuit, but potential difference is different. So that's why Vs equal to V1 plus V2 plus V3. So Vs equal to IRS, V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So I'm taking I common, I get cancelled, then you will be getting answer RS equal to R1 plus R2 plus R3. So if a number of resistors are connected in series combination, then RS equal to NR. RS equal to NR. So this is the answer. Now we will discuss about next one, that is resistors are connected in parallel combination. Resistors are connected in parallel combination, right? Yes. Resistors are connected in parallel combination. Parallel combination. Now resistors are connected in parallel combination. Parallel combination. Okay, so this is the R1, R2 and R3. So I am connecting potential difference. Here I am connecting potential difference. So V I am connecting here, V I am connecting here. So across R1, I1, across R2, I2, across R3, I3 is current is flowing. Right? So now you can see, okay. So now you can see current is, potential difference is same. So Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same, but current is different. Current is different. So current is different through R1 I, through R1 I1, through R2 I2, through R3 I3. Okay, then Ip equal to, from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. I equal to V by R. I equal to V by R. From Ohm's law, V equal to IR. I equal to V by R. Okay, so now you can see here, now you can see Ip equal to I1 plus I2 plus I3. Ip equal to I1 plus I2 plus I3. So then we can take, so V by Rp equal to V by R1 plus V by R2 plus V by R3. So I am taking V common. So if you take V common, then you will get the answer 1 by Rp equal to, so V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So I am taking VV common. So VV get cancelled. So the remaining values are 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the answer. Okay. So if n number of resistors are connected in parallel combination, then 1 by Rp equal to n by R. 1 by Rp equal to n by R. Rp equal to R by n. So this is the answer. So very very important. Make sure that you are practicing all these points. Once again, so three resistors are connected in parallel combination, R1, R2, R3. So battery connected, switch. So ammeter current is flowing, voltmeter is connected across R1, R2, R3. Okay. So potential difference is same. So potential difference is same in the parallel combination. So current is different. So that's why current in parallel combination Ip equal to I1 plus I2 plus I3. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So V I am taking common. So V will get cancelled. Then the remaining values are 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So then we can observe here 1 by Rp equal to n by R, Rp equal to R by n. I hope it is very clear. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Next one, heating effect of electric current. So potential difference V is directly proportional. Heating effect of electric current. Heating effect of electric current is nothing but the source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat. It is called, so heating effect of electric current. Okay. So now V equal to W by Q. So we know that potential difference V equal to W by Q. V equal to W by Q. So W equal to V into Q. V into Q. So P equal to rate of doing work is called power. Rate of doing electrical work is called electrical power. So VQ by T. So we know Q by T is current. Q by T is current. Yes or no? Q by T is current. So that's why P equal to V into Q by T, that is current, that is nothing but VI. So P equal to VI. P equal to VI. I hope it is very clear. So energy equal to power into time. So that is the heat produced in the conductor is equal to P into T. So H equal to what is P? VI into T. We know that V equal to IR. We know that V equal to IR. V equal to IR. So then we can take H equal to IR into I into T. Then we will get H equal to I square RT. H equal to I square RT. Heat produced in the conductor is directly proportional to current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay, so this is about heat produced in the conductor. So heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Okay, so next one, so we'll discuss. If you like the content, if you like the channel, so please do like, share and subscribe to Student the Brand. So inform to everyone, ask your friends to join to the class. So CBSE live classes are going on continuously. Support the channel in all the ways. So thank you for supporting those who are supporting. So please support the channel. Okay, inform to everyone. So definitely content will be good. So in that way, no compromise. Content will be good. So problems practice will be there. And okay. And doubt clarification session and remaining points, you can join at membership. So already it is there. So today already you took the members class. So you can join. Now I'll write one question. So I'll write one question. So inform to everyone, just you can check the videos of mine, previous ones. So if any changes are there, if you have any doubts, you can ask me. Okay, so if you like the content only, if you like my explanation, so please do like, share and subscribe and inform to your friends. So in our schoolmates, in our schoolmates, if you are there in college, inform to your college mate also and the near ones who are there. So just spread a one word regarding the channel. So that helped me a lot to reach maximum students, to teach maximum students, to reach me maximum number of students. Okay, so please help me in that journey. So without your support I can't able to do. So without your support I can't able to reach. So try to support the channel. So encourage the channel. Thank you. Okay, so question number so moving a charge of 2 coulomb from a point of 118 volts to a point at 128 volts. Okay, this is the question. So try to solve it. So let me know the answer. So I'll give 4 minutes time. So very simple. Let me know your answer in the comment section. So problems practice will go on. 4 minutes time. So the answer is 20 joules. Very good. Few members are mentioned. Okay. So congratulations for them. Very good. So I'm giving 5 star to you all. 5 star. Okay. So nice. 20 joules is the correct answer. Those who got the correct answer, subscribe. Those who didn't get also, no problem. Please subscribe. Okay. So definitely by trying, definitely will get it. So do hard work. Okay. So you have to be exist to get the success, right? So if you are there in the path of success, so at least you should be, working in that path. So if you quit the path, you can't able to get the success. So success will come definitely at the at one point, because it's a part of the success, right? Path of the success. So one point, next point, next point, next point, continuous. So like that, commas only, no full stop. So that's why be exist in the path. Definitely one day you'll get success. Okay, try so hard, do your work with whole heart and soul. Definitely you'll reach to your heights. This is the point. That's enough, nothing else. Do your work. Whatever you are doing, whatever the work you are doing. Okay, what are the work you are doing? You are a student, or you are a employee, or you are a, so whatever position it is, so do your best in that. Do your best. Be very strong. Be very strong enough to reach your goal. Okay, so even though your goals looks very strong initially, so gain your knowledge, gain your strength, gain your hard work, gain your ability to reach that point. Definitely in that path. So you're developing yourself. You are thinking only about success. So you're in that path, you're developing yourself. That is most important. Develop yourself to get the success. Okay, so success is waiting for you. So you have to improve yourself to get the success. Okay, success is always there. Definitely it will be always there. So if you are ready to get that one, if you are ready to get that one, so in that path you have to make yourself very strong. Okay, you have to make yourself very strong, then definitely it will reach. Okay, so then come to the point. So here V1 is 118 volts, V2 is 128 volts, and so charge Q equal to Q equal to 2C. Then we can say potential difference V2 minus V1 equal to 128 minus 118, that is 10 volts. So they are asking to find out how much work. V equal to W by Q. V equal to W by Q. From this, W equal to VQ. W equal to VQ. So W equal to V equal to how much? 10. And Q is how much? 2. Q is how much? 2. So answer is W equal to 20 joules. Okay, if you got the correct answer, if you like my explanation, please subscribe. Please subscribe for, please subscribe. Then for more videos you'll get it. Subscribe. Okay. Then only you'll get, whenever I'm taking live classes, you'll get to know that. So try to subscribe the channel and share this channel to everyone. Ask them to join to the class. If you like the channel, if you like the explanation, okay, just check once. Subscribe, right? Yes. So let me know whether it's completed or not. Once again I'll explain, just check once. How much work is done? So they're asking how much work. So how much work? How much work means we have to find out W. So it's done to moving a charge Q, and V1, V2. This is the final position. So V1, V2, charge V2 minus V1 is 10 volts. Final value is V is 10 volts. So we can take V is 10 volts. Then V equal to W by Q, W equal to V into Q. So W equal to 10 into 2, then you'll get 20 joules. Thank you. So I'll write one more question, just check once meanwhile. So next question is, so I'll write the next question, check once. Okay, so let's try this question. A wire of given material, a wire of given material having length L and area of the cross section and the area of cross section A has a resistance of 10 ohm. Okay, what would be the resistance of another wire, another wire of the same material, having length 1/4 and area of the cross section so 2.5 ampere. Okay, so just check the question. So if you like the content, so just go through the so 4 minutes time, again 4 minutes time. So please subscribe, just check once. Please subscribe for channel. Subscribe for more practice videos. Okay, just check once. So very good. Those who said one is correct answer. So how it will be, I'll explain. Just check once here. Here you have to observe one thing. That is, so first you have to underline, okay, what is given. A wire of given material having length, so length and area of the cross section has a resistance. So that is nothing but given data. Given data, so the data is given L1 equal to L2, sorry, A1 equal to A1 equal to A, and coming to the resistance, R1 equal to 10 ohm, right? So what would be the resistance of another wire of same material? So here you need to understand rho 1 equal to rho 2 means same material, resistance is same, and having the length L2 is L by 4 or 1 by 4 into L, okay. So having length, what is the length? You can check once. 1 by 4, that is L by 4, and area of the cross section is how much? Area of the cross section is A2 equal to 2.5 ampere. So this is our data, so you have to focus on this one. You have to focus on this one. Okay. So the formula is R equal to, we have to find out, so what they are asking to find out, what would be the resistance of another wire. So we have to find out R2. R2 is the R2 value you have to find out. Okay. We know that R equal to rho into L by A. R equal to rho into L by. Anyway, resistivity is same. So condition is, so rho 1 equal to rho 2. Anyway, material is same. Material is same. Okay. So material is same material. That's why rho 1 equal to rho 2. In that case, we can write R1 by R2 equal to L1 by L2 into A2 by A1. Because inversely proportional, right? Inversely proportional. So that's why now we can say R1 is how much? 10. R2 we have to find out. L1 by L2 equal to how much? L2 equal to L by 4. And so A2 equal to how much? 2.5. 2.5 into A by A. Okay. So now you can see here. So we can cancel LL. We can cancel LL A. So then 10 by R2 equal to, so how much will get? So 4 into 2.5. If you cross multiply, how much will get? So R2 equal to 10 by 4 into 2.5. Okay, so then 10 only, right? Yes or no? So 2.5, 5. Again 2.5 plus 2.5, 5. So 4 into 2.5 is 10. That is 1. So R2 is 1 ohm. 1 ohm. So this is the answer. So if you like the content, if you like my explanation, please subscribe. Okay, so subscribe. So no place. So remember and subscribe. Okay. Subscribe the channel. Subscribe. Subscribe. Okay, you can subscribe the channel for more videos. Okay, check the explanation. So if you are not getting, let me know. Once again, I'll explain. So I hope you get it. So I'll discuss one more problem. Be ready for it. So you can see here. So resistance of a metal, wire of length 2 meter, wire of length 2 meter is 30 ohm at temperature 25 degrees centigrade. If the diameter of the wire is 0.6 mm, then what will be the resistivity of the metal at that temperature. Okay, so that is the question. So I hope it is clear. So again 4 minutes. Try to solve it. Try to solve this question. 4 minutes time. So understand the given data. 4 minutes time. And please subscribe for those who are new to the channel. Those who already, ignore if you already subscribed. If you did not subscribe, please subscribe. Okay. So because you'll get live class updates, that's why I'm asking to subscribe. Okay. So here you can check once. So first you have to identify the given data. You have to identify the given data. Then you will get it. Okay, check once here. First you have to identify. So resistance of metal wire length is L, and so resistance R, a temperature, so diameter of the wire, diameter is given D, and then what will be the resistivity, so they are asking rho, so of the metal of, so at the temperature anyway, so there only they are asking. Okay, very good. So someone said 4.24 into 10 power minus 6. 4.24. Okay. Correct. Very good. So, okay, check once. So, how much will get? Here I am taking actually, so 4 point or 47 point or something. So, but 10 power minus 6 is correct, but 4 in that only. Maybe calculation here and there it will go, but still. So, once again, if you try, then you will get it. So, here L equal to, first you have to write the given data, L equal to given data. So, try to solve your own. 2 meter and resistance is 30 ohm, length is 2 meter, resistance is 30 ohm, and diameter, so diameter is given 0.6 mm. So here is the point, so we need to convert into meters. So then we have to find out the resistivity, right? So rho we have to find out. So here diameter D equal to 2R, R equal to D by 2, R equal to D by 2, that is nothing but 0.6 by 2, 0.3. But still, so that is in mm, so 0.3 mm. So we know 1 meter equal to 100 centimeter, 100 centimeter, 1 centimeter equal to 10 mm, 10 mm. So if you are taking 1 meter equal to, so 10 power 3 mm, so 1 mm equal to, so 1 by 10 power 3 meter, then 1 mm equal to 10 power minus 3 meter. So you have to take this value. Okay. So this conversion also very important. Conversion also very important. So this converts 1 mm, but here they given 0.3. So R equal to 0.3 into 10 power minus 3 meter. That is the final value. So here I am erasing. Just check once. So we need to find out resistivity. This is the calculation. L given. So 2 meter. Resistance given 30 ohm. So diameter is given in mm. Must be converted into meters. You have to convert into meters. So resistivity we have to find out. They're asking what will be the resistivity. So temperature. So at that temperature only they given. So R equal to D equal to 2R diameter. Radius equal to 2 by 2. 0.6 by 2. That is 0.3. So this is the conversion. So make sure that you are learning this one. Okay, so just check once. Right now, now you can see now. So R equal to rho into L by A. Now rho equal to RA by L. This is the value, right? So rho equal to R how much? R 30 and area equal to pi r square. Okay, pi r square. Even you can take, so here you can take D equal to D by 2 whole square also you can take. Okay, so D equal to here, instead of R equal to D by 2 you can write, so in this place pi r square, D by 2 whole square also, if you want to substitute, so pi D by 2 whole square you can substitute and write, no problem. But it will become very lengthy. Okay, so we can't able to calculate properly. So again you will get so many complications. So while you are solving the calculation, so try to make it simple. Okay, na? Try to make it simple. So calculation must be simple. Then only we can able to do fast and save the time in the exam hall. Okay, so try to learn the techniques to make it simple. Okay, so first you can see here R equal to rho into L by A. So here rho equal to how much? So R equal to how much? 30, and area equal to how much? Pi R square. Pi is nothing but 3.14. You can take it. So I'm writing directly. Just check once. So here I will write pi R square. So I am writing pi means 3.14 into R square means this is the value. Okay, 0.3 into 10 power minus 3 whole square by, so L value how much? 2 meter. Okay, so try to solve it. So what is the answer? You let me know. Rho value. Just do the calculation. Do the calculation. Try to do your own. Okay. So I'll give one more problem after this. So if you like the content, subscribe. Subscribe. If you like the content, if you like the explanation, please do like, share and subscribe the channel. Like, share and subscribe. Okay, if you like the content, and let me know the answer. Okay, just let me know the answer. I'll give, just write. So this question is very important. Just try to solve it. A piece of wire, a piece of wire, a piece of wire of resistance 20 ohm is drawn out so that its length its length its length increases its length increases to twice to twice to its original value, twice its original length original length original length. Okay, so calculate so that its length increases to its original length, twice to its original length. Calculate the resistance calculate the resistance of the wire in the new situation new situation new situation. Okay, so try to solve it. So try to solve this question. Let me know the answer. 4 minutes time. So less than that only I will explain, but I have to give time, right? Without time limit we can't. So 4 minutes time. 4 minutes time. Okay, so subscribe for more physics problems. Subscribe. Okay. Now you can observe here, can check once. I'm here only, I didn't go anywhere. So even I'm not writing songs, so I'm working on physics problems. Okay, so now first you see, so resistance is 20 ohm, given data, okay, so how much R equal to 20 ohm, and so that length increases twice, here length, so twice in the sense L1 is L, L2 is 2L. So here if it is this one L, if it is twice, then area is decreases. So initially area is, so final area is A by 2. This is 2L. Okay, this is, now L2 is 2L, A2 is A by 2. Okay, so they are asking to find out resistance R2. Okay, here you can observe R1 is 20 ohm, and here is A1 is A. Okay, so here you can observe one thing, that is, so normal formula is R equal to rho into L by A. So here in these two cases rho is same, because here same metal one is drawn out, same metal is drawn out, so automatically resistance is same. So R1 equal to 20 ohm, L1 equal to same, initially A1 is A. So after drawn out, length increases twice and area decreases A by 2. Okay, area decreases. Then R2 we have to find out. R equal to, so here in this case, R1 by R2 equal to, anyway rho is same, L1 by L2 into A2 by A1. Okay, A2 by A1. R1 is how much? R1 is how much? Okay, R1 is 20 ohm. So 20 by R2 we have to find out. L1 is how much? L1 is L only. L2 is 2L. L2 is 12 and A2 is A by 2. A2 is A by 2 because area is decreasing, right? So A by 2 and original A is A. So we can cancel now here. So A get cancelled, LL get cancelled. Then 20 by R2 equal to 1 by 2 into 1 by 2. So 4. If you cross multiply, R2 equal to 4 into 20, that is 80 ohm. The answer is 80 ohm. Who got the answer? Let me know. Anyone got the answer? So answer is 80 ohm. If you like the content, just subscribe. Subscribe the channel. Okay, where? Subscribe. 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 Okay, so, oh sorry. Subscribe. Now you can observe. Now you can observe here in this case. Here you can observe, subscribe. Now you can observe once again. So a piece of wire of resistance, a piece of wire of resistance is 20 ohm is drawn out. So here you need to understand drawn out. Drawn out so that its length increases to twice of its original. Calculate the resistance. Original length means L. So increases twice. So then area decreases A by 2. So R2 we have to find out. Normal formula is R equal to rho into L by A. Then R2 we have to find out. Anyway, rho is same. Why rho is same? Because same material only. Okay, same material. Material is not changing. So by that R1 by R2 equal to L1 by L2 into A2 by 1. Then if you substitute the value, you will get, so R2 equal to 80 ohm, right? So if you like the content, if you like the channel, if you like the explanation, please do like, share and subscribe to Student the Brand. Just check once, 2 minutes. I'll give one more question. Okay. Just check once. Okay, so let's try one more question. One more question, one more question. Let's solve, let's solve, let's solve. So next question is, so try to solve this one. An electric an electric iron an electric iron of resistance 20 ohm 20 ohm takes a current a current of a current of 5 ampere 5 ampere. Calculate the heat calculate the heat developed calculate the heat developed in 30 seconds. In 30 seconds. Okay, so try to solve this question. So if you like the content, if you like my explanation, do like, share and subscribe to Student the Brain. And 4 minutes time now. 4 minutes time. Okay, subscribe. Subscribe for more videos. Okay. So okay, so what is the answer? Answer is yeah, very good, correct. So how many years said? Only one, right? So 15,000. So correct answer. Okay, done. 15,000 joules. So 15 kilojoules also we can write. So let's solve this one. So here given data, what is the given data? R equal to 20 ohm, R equal to 20 ohm, and current is given, so 5 ampere. So you have to underline the given data, or you can round up, so fine. So here is current and resistance and time is given. So this is R, this is I, and this one is T. Okay, so T equal to 30 seconds. Now we know the formula H equal to I square RT. This is the formula, right? Then H equal to I how much? 5 whole square into R equal to how much? 20 into, so T equal to how much? 30. T equal to how much? 30. So what is the answer? Yeah, correct. Oh, nice, nice. Maximum members are attempting answers. Great, great. Keep it up. Okay, so answer is, so 25 into 20 into 30, that is 1500, 1000, 100, 1000 joules. So we can take H equal to 15 kilojoules. Okay, this is the answer. Subscribe for more explanation videos, more for live classes. Subscribe. Okay, so just check once. I'll give one more question. So okay, so one more question. So let's solve. So one more question, one more question, one more question. Okay, let's try this question. So an electric heater, an electric heater, electric, an electric heater of resistance 8 ohm draws 15 ampere from from the service from the service means for 2 hours calculate 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 the rate at which the rate at which heat is developed heat 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 is developed it is developed in the heater. So this is the question. So try to solve it. So if you get the answer, let me know. Okay, so meanwhile go for subscribe. So my here maximum members are telling 192 like this kilowatt hour. So they asked if rate at which heat develop means power. They are asking the power even though they given time. Okay. So even though you given time, so you do one thing. So I'll tell in two methods. Method number one. So method number one is, so find out I square RT because I is given here. So I'll tell in two methods, just try to solve it. So current is given, resistance given, I square RT, and time also given 2 hours. So first find out and then you can do it H by T. So this one by T, then again it will get cancelled. So that will become power, right? So anyway, what is the formula? I square R. Anyway, the final formula I square R only, right? So you can find out directly P equal to I square R. If you do this method also, you'll get the same answer. So here, instead of writing here, you can take it here. So find out H, heat produced. If you are not getting the answer, you can do it. H first you find out, then heat rate or rate at which heat is produced. Rate at which means H by T. Then you can solve it. Otherwise, directly you can do it like this. Then you will get the same answer. So that is I square how much? So 15 whole square into R how much? R is 8. Then you will get 800 watts or 1.8 kilowatt also fine. Okay, so then you can do it. This is the answer. Find out, just multiply, you'll get the answer. Clear? So that's enough. So just try to focus on what they given. So what they asked. So rate at which heat, the rate at which heat is mean, this is the formula. That is nothing but power. Okay. So next I'll give one more question. Meanwhile, just check once. 1 minute. Okay, so thank you so much for joining and attending and listening. So again, I will start the class around 9:30 to 10. So around that time. So between 9:30 to 10. So join to the class. Do like, share, and subscribe to Student the Brand. So keep updating. Click on bell icon. So then automatically you'll get the live classes updates. So thank you so much for joining and attending. So please support the channel. Please encourage the channel. Inform to everyone. Okay. So please do like, share, and subscribe. So this is our Seva from Student the Brand. Thank you so much for joining and inform to everyone. And again, if you like the content, if you like the channel, if you like my explanation, please go for super chat, super thanks, and membership. So thank you so much. We'll see you in the next class. Thank you.